Everyone, hope you're doing well. I want to go over a few of the ANOVAs with you guys so that you feel ready and like you've got a good handle on what you need to do and how to differentiate between the different kinds. I posted separately another document. If you look on Moodle, the very last item should be ANOVA practice. And there are several problems there that you guys can practice on your own. And I'm going to post the answers to that probably by Sunday. This way you guys have some time to work on your own. Sunday's Easter. I am not going to do that. I'm going to do that on Monday. So this way you guys have time to practice it and verify your responses. So I want to work through a couple of problems first. So this would be a good time, and I did not really think this through if there's a way for me to have a whiteboard as part of Zoom. I'm not super Zoom. I think there is a way to have a whiteboard right here. Okay, yay, you do see it. Ish. Okay. Um, Communicate with comments. No, thank you. Let's just leave that. Okay. Uh, let's keep it here. I don't know why it's giving me all of these options. I'm just gonna, oh, I don't think that's what I should do. But anyway, um, so we're gonna talk through a problem. And I'm going to read part of the issue so we can go through. So the first step here is this is a typical ANOVA problem. The ANOVA is as such. There are 15 third grade students that participated in a memory experiment. 5 students had a story read to them by a teacher, 5 read the story themselves, and 5 saw a video of the story. Each student then took a memory test on 12 items from the story. The children who heard their teacher read the story recalled an average of 5 items. Those who read the story had an average recall of 9 items, and those who saw the videotape recalled an average of 10 items. Okay, so that's kind of the basics. So first we need to write down what is our sample. So we have a total of 15 students, right? Oof, I wish that I could just type because my handwriting is not that great. Can I type? Yes, I can. This will be way, way better. Let's make this guy bigger. Okay. So we have 15 students and we have 3 groups. They're evenly divided in the 3 groups. So just looking at that, you should be able to get the degrees of freedom. This is basic ANOVA, okay? So we need to look at between and within. That is the focus of a basic ANOVA, okay? And then we ended up getting some means, right? So means for each group. And now we're running up into a space issue. If I can scoochy scooch. This is why it's best to have an actual board. I'm not an online teacher for a reason, huh? Let's go back and see what our means were. So we have the story recall from the teachers 5 items. Those who read is 9, and those who saw a video is 10. So talk is 5. Read is 9, and then video is 10. Okay, these are the different means for our groups. We care about that because that is going to impact, obviously here I can make that smaller, that's going to impact the group differences. So if I was looking to do a table, I would be including, and this is, again, I've made this clear, you guys are not going to be calculating sums of squares, means of square. Those will be provided for you, but you do need to know how to figure out degrees of freedom. So hopefully from this, you guys know what the degrees of freedom are. Okay, I'm not putting it up on purpose so you guys can have it written out kind of on your own, and then you can see what that number would be. But we essentially have 15 students. There's 5 in each groups, and there are 3 groups, okay? We will then need to figure out our F critical. Let me see if I can share my screen. Yes, let's close the whiteboard option. And of course, that's giving me nothing. So hold on, let's close this. Okay, good. You guys see me again. I will then show you, I'll just show you this. That'll just be a little faster. I will, whoops, show you guys where's our screen? Right here. And we are looking at this. Okay, hopefully you guys can see this. So this is our problem here, our third grade students. Hopefully you guys all got that our between group, K minus 1 is 2, right? Because we had 3 treatment groups or 3 different groups. Our within group, we do total N minus K, so 15 minus our groups, which is 3 different groups, so that gives us 12, okay? This is what I meant. We have the sums of square here. You have the mean square. Obviously, mean square is the means of square between divided by means of square within. That gives you an F score of 4. But first, you need to figure out what is going to be your F critical. Hopefully, you guys all remember F critical. Let's go over here so you guys can see from my lecture. This is all something you can have on hand, but you calculate F critical by looking at the degrees of freedom between, that ends up being your numerator, against the degrees of freedom within, that is your denominator, okay? So degrees of freedom between is at the top, degrees of freedom within is along the side. So that's what happens when you teach via Zoom. I just have so many pages open. Now I need to show you guys this guy, which is our F table. And our F table looks like this. Now, hopefully you guys can just click it or open it on your own, right? So looking at this F table, F tables can be found online. It's all the same, right? It does not change. So if you look up here, our numerator, right, is DF between. We had 3 treatment groups minus 1. That gives us degrees of freedom 2. So we're going to be looking here at 2. And then our degrees of freedom within ended up being 12. So I go all the way down till I see 12. And I end up with this number here, 3.89. Okay, that is my F critical. That is what I'm going to compare my F value to. Okay, now if we go back over here, hopefully you guys can see this. Our F value was 4. So based on that, do I reject the null that all my means are the same? Or do I actually, whoops, I picked the wrong one. Sorry. This is what happens if I start talking too fast. Here it is. Do I reject the null or do I fail to reject with an F of 4? Right? So let's take a peek at how I do this again. If I look at my whiteboard, which is right here. Okay, here we are. We now know our degrees of freedom here. We've got DF within, that equals 12s, that equals 12. Our DF for between, that equals 2, right? And now I can also say my F critical, that equaled 3.89 according to our table. And my actual F value is 4. So if we remember, let's draw it out here, right? This is what it looks like. This is our F graph, okay? We're way over here. This is our critical value that's predetermined based on our degrees of freedom. So 3.89, okay? And then I see that actually my F value is over here at 4, right? This is F equals 4. It is therefore in the rare zone, so I reject the null that all the groups are the same, okay? In fact, if I were to just look at it, I can see that there's a mean difference in their performance. Those who just heard it said remembered 5 items versus those who had the story read to them remembered 9 items, and those who watched a video about it remembered 10. So this is when we could do a test of honestly significant difference, okay? Remember, this is called our HSD. Let's go back over here. Okay, so if I am trying to figure out the honestly significant difference, for this value, it is 2.25. So in order to determine if there's an honestly significant difference between my values, I would need to do three separate comparisons. So group one versus group two, this would be talk versus read, and I do the difference, that's 9 minus 5. And then I make that difference. 9 minus 5 is 4 last time I checked. 4 compared to my HSD of 2.25. Yes, that is significant. Then I compare group 1 to group 3. That would be those who heard it versus those who watched a video. So that's 10 minus 5. Difference is 5. 5 is greater than 2.5, so that is also significant. But now here's the difference between those who read about it and those who watched a video on it. That difference is only 1. That does not meet the honestly significant difference threshold to be significant. So I can then conclusively say that I reject the null, that students remembered the items from a class in the same way, right? The scores were not all the same. Therefore, the presentation style mattered. And more so, I can then speak to the groups. It seems like there was a significant difference between how much students remembered if they read about the story versus heard it, or if they saw a video rather than heard about it. But there was no significant difference between reading the story and watching a video on it. The reason why we do these kinds of research projects is, for this example, to figure out what is the best modality of teaching that will lead to the greatest amount of retention. And the go-to kind of quick takeaway message here is there's not really a significant difference between reading it and watching a video, but they are both significantly better than if a student is just sitting and taking in the information from a teacher talking about it. Okay? This would be an example of our original, like the OG ANOVA, okay? I'm going to create another video on the repeated measure, and then we'll do a video on a two-way ANOVA, which is what we started covering yesterday, okay? So I will see you guys later.